Hi, good evening, everyone. Ayan. So, welcome. Good evening.
Good evening.
Welcome to another episode or another session of Alpha TV, brought to you by, of course, As Like Speech Academy. And before we jump into the session for tonight, so unfortunately, we're like very thin in terms of manpower this evening. So I'll be your facilitator as well as your mentor for tonight's session. So before we jump into the formality of the session, I would like to ask people who are in the session if you could like invite your friends and colleagues or classmates and to join us here at Zoom. We're also live now at our YouTube channel, As Like Speech Academy, because we have like 80 more seats here at Zoom. And I'm not assuring you anything, but I think this session will be a helpful one, especially if you're a student or you're a professional doing data analysis and all that. So, all right, moving forward, we would want to express our gratitude to these partners for making this learning session possible. We have IXL Online CIE Review Center. If you're a graduate of any Alpha Premium program, you have now access to another or an additional 500 pesos off. Okay. We have Blessed PH, formerly Grace Apparel. They're actually rebranding tomorrow. Congratulations to one of our partners. Startup Podcast PH, of course, our official podcast partner. And TUOS, the first Filipino cloud-based analytics platform. You might want to go to alphatuos.com and register for an account because we'll be using TUOS as our platform for tonight's session. So you will have access to 90 days, not 30 days. Okay, 90 days free trial. This is just up until I think this March, and we'll be reverting back to the 30-day trial, and then after that we'll be having paid, of course, paid subscriptions moving forward. Okay. So who's the keynote speaker? Of course, the keynote speaker is none other than me. So my name is Felix Concepcion Veroya, and I'm Felix Concepcion Veroya, the founder and CEO of As Like Speech Academy, and at the same time, the Chief Strategy Officer of TUOS, the first Filipino cloud-based analytics platform. So data analytics made easy. Okay, we will be using TUOS later on. Okay, for this topic for tonight, I actually enjoyed preparing the material for this one. Finding the relationship that matters. This is supposedly a talk during the February celebration of love or the love month. So hypothesis testing using TUOS, but it so happened that we have like so many things happening in the background, and it just happened that this is the session, this is the time that we were able to make it, or me personally. So you would want to prepare for something that's really I would say entertaining, in a bit or in a sense, integrated with something that's going to be useful for you and in the future. Either you're a student now or you're a professional here in this particular session. So again, I would appreciate if you would invite, or if you could invite your friends and colleagues to this room, since we have a lot of empty seats here, empty virtual seats here. So let me go to my presentation for tonight. Well, of course, just give me a couple of seconds. I'm gonna give you also the link to of course, the data, because we will be using a data here, right? So let me try to look for it. Okay. So, please go and to your you don't have to download anything, but you have to create an account so that you can have access. Okay, again, 90 days, not 30 days. So if you're doing like a research or study in your office, this is going to be a good opportunity for you to try out TUOS. So I'm gonna give you yeah, this one. In our okay, in this particular Zoom chat box, I was able to provide you with, of course, the link to the data that we will be using. Now, if you are in YouTube, I also shared it in the comment section or chat section. All right, so let's proceed with the tonight's session. Okay, finding the relationship that matters, hypothesis testing using TUOS. Okay, so again, my name is Felix Concepcion Veroya. I'll be your mentor for tonight. So if you're here, I really wanted to do this kind of game. So if you're here, you're participating in this particular session, please join also my mini game. You have all you have to do is to upload a photo of you watching or participating in this particular session tonight. Share that photo, but of course, don't forget to tag our page, Aztecs Page Academy, and there's also a page for TUOS. So that's just TUOS or TUOS, and use the hashtag significantly better with TUOS, and you learn something tonight, and you might have also a chance to win one of the 200 pesos GCash or Maya credits and access to this e-learning course that we have here. Okay, so if you would want to participate, I would highly encourage you to do that. Anyways, jumping into the session, that's me. Of course, I've been into the industry like more than a decade already, 11 years, and my main expertise, or I would say experience and expertise, revolves around innovation, sustainability, analytics, and continuous improvement, specifically Lean Six Sigma. All right, so are you one of them? Are you one of these two kind of persons? No, you might be here, you're a student who is struggling with your data analysis for your capstone or research, or you might be this, professional finding it hard to analyze data for your company studies or projects. If you are here and you belong to the first one, can you type in number 1? And if you're here and you belong to the second group, can you type in number 2 in either the Zoom or YouTube chat box? Come on, guys. Let's do this for the next 1 minute. I need your engagement, and so that I know if whether I have active listeners. Okay, we are now here 31 in the Zoom. If you still have friends or colleagues who might want to be inside Zoom, please, please, please invite them to do so. So I have now 1/3 of the people in the room responding. So I can see here that most of you are students. All right, thank you for attending. All right, so either or, data analysis has been very critical as a skill set, especially nowadays. That's why we've crafted this session so that we can provide value in terms of how you would really want to do or how you should do it in a more appropriate manner, the data analysis that you're doing inside your organization or in your future organization for the students and to their research at this current time. Okay, so what's up ahead for the next couple of minutes? I'll try to finish as on time as possible. We'll be dealing with what is hypothesis testing, what are the steps to hypothesis testing, what are the ways on how to find the differences or relationships between variables. I'll be presenting a use case, and of course, we'll end up with my reflections, my hashtag reflections, and some sort of Q&A for if time permits. Okay. All right, so I want you to focus in this picture because we're talking about hypothesis testing. So let's start with the concept of hypothesis. What could they be talking about? All right, in the Filipino culture or landscape, we call it marites, right? No, what could they be talking about? Okay. Type your hypothesis in the Zoom chat box, and I'll try to read some of them. Okay. So come on, guys. Try to put in what could they be talking about? These two persons here. Okay. So I'm gonna give another minute to do this for you to participate. What could they be talking about? Any idea or any inputs? No wrong or right answers here. Okay, someone sent me a personal message saying that they could be talking about a project, sir. That could be. How about the other participants in the Zoom session or even in the YouTube side of this particular learning session? What could they be talking about? They could be talking about how they could reach their goals. Correct. Okay, what else? Come on, guys. Our research. Okay, what else? Some more, few more. And then we'll process. Brainstorming. Brainstorming about what? Okay. Thank you for those who participated. All right. So for the benefit of time being, okay, they could be talking about things that we don't know, right? So why are we doing this particular exercise? Because we're talking about hypothesis. Hypothesis, if we will draw back to the roots, as early as maybe our um secondary secondary education days or high school days here in the Philippines, we are, we've been taught of hypothesis, an educated guess. It means that we don't have the evidence yet until such time that we collect data and try to prove it. And that's why we're talking about hypothesis testing. So we have a hypothesis, and it's either it's gonna be we're trying to prove or disprove that particular hypothesis. So that's why. Now let's take into account, what does Sheldon know about this. Maybe you're quite familiar with the Big Bang Theory. So let's watch this.
You went to space?
Interesting hypothesis. Let's apply the scientific method. Perform an experiment.
Okay. Hey, Howard, any thoughts on where we should get dinner?
Anywhere but the space station. I mean, on a good day, dinner was a bag full of meatloaf. But hey, you don't go there for the food, you go there for the view.
Fascinating. Let me see if I can duplicate the result. Howard, I've always thought the lemon was an underrated fruit. Care to weigh in?
Not really.
Oh, well.
You know, people say the Soyuz capsule is a lemon, but... Yeah, but hey, that baby got me to space and back.
Have you noticed that...
All right, so that particular video talks about having that kind of hypothesis, and they tried to test it. So they collected like data or data points, right? To Sheldon's point, we need to replicate whether it's not by chance. Is it that when his friend asked Howard about this, is it just happened that it happened by chance, or is it something that's really there? Okay, so that's how hypothesis testing works. So you have like the hypothesis and you try to test it, you use data to prove or disprove. So that's going to be the whole point of what we will be having for tonight. All right, so
Howard can take.
what is hypothesis testing? Because form of review, hypothesis testing is a statistical method used to evaluate a claim or hypothesis. Okay, see the term claim about a population parameter based on sample data. So it's typically, okay, you have like so many data sets and then you try to prove or disprove a hypothesis using a portion of the whole data set or the population at large. So that is why this particular tool falls under what we call inferential statistics. So the goal of hypothesis testing is to assess whether the evidence provided by the sample data is strong enough to reject the null hypothesis in favor of the alternative hypothesis. So we will be talking more about this kind of hypothesis in the most practical sense in the next coming slides. Okay. So what are the uses of this hypothesis testing? So there are a lot of uses, and these are some. So it allows us to determine statistically whether or not a value is cause for alarm, and it's cause for alarm, meaning, say for example, hey, I have this data, and if I compare it to the target value of this data, it's either good or not good in terms of how it's performing. So if it's not good, is statistically not good or statistically different, they would say that, then we have to do actions, okay? Or we have to implement something to address that. It also tells us whether or not two sets of data are truly different with certain level of confidence. And in hypothesis testing, you'll always hear confidence level. So when you're trying to compare two data sets, say for example, if you would want to compare, let's say, the salary of fresh grads versus the salary of those who've been in the industry for like around 5 years, is there really a significant difference? So hypothesis testing could help you out. Or is the, let's say, we could say that the salary of people who have like around or average of 5-year experience is more than those with lesser experience or fresh graduates. It could also help us tell whether or not a statistical parameter, so it could be the mean or the standard deviation or other statistical parameters, is different from a value of interest. So is the average salary of a fresh grad, let's say for example, if you started working or when you started working, is the one that has been offered to you comparable with the industry standard, something like that? So we could use hypothesis testing for that. It also allows us to assess the strength of conclusion or our probability of being correct or wrong. And later on, I'm gonna share with you some errors when we are doing hypothesis testing. Okay, so bear with me on this because we really need these concepts so that the use cases will be as smooth as possible, right? Okay, what are the common applications of hypothesis testing? Okay, so these are some common applications. We can talk about the difference, a difference of a parameter, an average or standard deviation, to a target average or target standard deviation. You could also talk about association, whether, let's say, is salary associated with the number of certifications that I have taken before applying for a job. Okay, it's called association. We could also say relationship. Is there any significant relationship to the probability of me getting my job, okay, as fast as possible versus, or the time that I've taken or I've had my first job, as against to the number of applications that I have sent? So that could be a matter of relationship. So this major or common applications will be also presented later on to you. Yan. First, when we do hypothesis testing, there will be hypothesis statements or hypotheses, right? Now, in the context of hypothesis testing, we have two, okay? And these are the two. We call the first one the null hypothesis. This is actually the one that we are testing out. And of course, to back it up, okay, if we don't have enough evidence to prove that, that the first statement, the null hypothesis, is correct, that's the moment that the other hypothesis statement will come into the picture, and we call it the alternative hypothesis. Okay? So the null hypothesis is the one that we're testing, and then the alternative hypothesis, as it suggests, is the alternative one. Okay? So null hypothesis is also called HO, and alternative hypothesis is called HA. HOHA, right? So HO is a statement being tested to determine whether it is true. Okay? And the alternative hypothesis is a statement that represents reality if there is enough evidence to reject HO. Okay? So if we have like enough evidence to reject the null hypothesis, so which one remains? The alternative hypothesis. Meaning the alternative hypothesis holds true because we don't have enough evidence to say that the null hypothesis is true. Something like that. Okay? So what are those statistical statements? Okay? We call it the statistical statement. So meaning HO, when you say that HO, typically it talks about being no difference, no significant difference. That's the keyword. No significant difference or no significant relationship. Okay? So let's focus on no significant difference. So if the average population average 1 is equal to population average 2, meaning if they're equal, meaning there's no difference on their averages. So when we convert it, having 0 on the right hand side, that's going to be mu1 minus mu2 is equal to 0 because there is no significant difference. Therefore, when you subtract the latter from the former, that's going to be a difference of 0, something like that. So that's the main concept. And the other way around, when you talk about the alternative, this talks about statements that relates to there is a significant difference or there is a significant relationship. So we're talking about population average 1 not being equal to population average number 2. Or if we will use 0 on the right-hand side of the equation, that's going to be mu1 minus mu2 is not equal to 0. Why? Because there is a significant difference. Okay? So that's how it works. Now, let's have some examples. For the first example, we're talking about the prelim exam score in stat. Okay? So the null hypothesis is there is no significant difference between the average scores of male and female in the statistics prelim exams. And on the other hand, I would appreciate if you could be mindful of your microphone so that you'll not be disturbing the entire class. Thank you. So the alternative hypothesis for the first null hypothesis in the first example would be, so you just have to remove the word no. So there is a significant difference between the average scores of male and female in the statistics prelim exams. So again, the null talks about having no difference or having no significant relationship, while the alternative talks about having a significant difference or having a significant relationship between the variables. Okay, another example. For null, there is no significant relationship between exam scores and length of study period. Okay, so we're trying to prove or disprove whether based on the evidence that we will be collecting or that we have, there is no significant relationship for the null between exam scores and the length of study period. While on the alternative, just remove the no, there is a significant relationship between exam scores and the length of study period. Okay, these are some examples of the hypothesis statement. So later on, I'll be sharing with you some more examples, and of course, we'll be dealing with the process of how we really do the hypothesis testing. Okay? So what are ways to assess hypothesis statements? If you're here as a student, or of course, everyone has been a student prior to this particular class, we've been thought of like at least maybe 3 ways on how to assess hypothesis testing statements or results of the hypothesis test. And these are 3 ways. Number 1, the critical value. This is the one that is being taught to us. This, I would say, that is the manual method, the by hand method, I would say. Confidence intervals, and of course, p-value method. So let's try to refresh what are the rules on when to fail to reject or to reject HO. In hypothesis testing, we only say that we will fail to reject HO because we don't have enough evidence based on the data that we have collected. We don't have enough evidence to reject it. So we don't accept it. We only say we fail to reject HO, or we fail to reject the null hypothesis. So if we don't have enough evidence not to reject it, okay, then we reject it. Okay, and what holds true with the evidence that we have? The alternative hypothesis. So when we reject HO, the null hypothesis or HA holds true with the evidence that we have with certain level of confidence. Okay, so critical value method. So we're gonna just do some like review for this. We're not gonna go very deep on this. So we have what we call test statistic. So what is a test statistic? Test statistic is the one that you calculate with all from the sample that you were able to get from the population. You try to calculate it. This is based on the hypothesis test, okay, that is being used. Okay, we compare it to what we call a critical value. What's a critical value? As you may already know or may not know, okay, if you may already know or may not know, okay, so we may look into the table or table of probabilities, or the probabilities under probability distributions. The most popular one is the normal curve. Okay, so there's like a probability that ranges from 0 to 1, as we may already know. Probabilities, or the sum of probabilities, will be ranging from 0 to 1. Sum of probabilities will be equal to 1. Okay, so we try to compare the calculated test statistic and compare it to the critical value that is from the standard table of values with certain degrees of freedom. Okay, so if you would want to learn more about these terms, you can search for Google, or you can approach me offline. No, okay, so we compare it. If the absolute value of the test statistic that has been calculated is less than or equal to the critical value, we fail to reject HO. While when the absolute value of the test statistic is greater than the critical value, we reject HO. So that's the first rule. The second rule, I love using this rule. Very useful, very straightforward. Confidence interval. What's confidence interval? The confidence intervals are intervals that we calculate from the test statistic. Let's say you're talking about average. So from the average, there will be like a lower interval or higher interval. And these intervals are based on the number of samples that is being used, and the standard deviation that is calculated or derived from the sample data. So when you put the intervals from the mean, so there's going to be plus minus certain number of standard deviations so I think that the basic formula would be the average plus minus z multiplied by the standard deviation of the mean, something like that. And that will give you let's say if you have like an average of 10, that's going to be, this just quick hand. Let's say 8 or 12. 8 for the lower interval and from 12 for the higher interval or upper interval. Okay. So that is like the confidence intervals. Okay. Now, how do we use it? So for example, you have like a value. You have like a certain value. When you look up into the confidence interval and that value that you're looking for is within the interval, you fail to reject HO. Okay? Because the interval covers that hypothesized value. When the hypothesized value is not within the confidence intervals, that's the time. So if this is your confidence interval and probably your hypothesis value is somewhere here, okay, then you say that you reject HO. Okay. Again, when you go to fail to reject HO, there is no significant difference or there is no significant relationship. When you go reject HO, there is a significant difference, there is a significant relationship, something like that. So always remember that. And the most commonly used is the p-value, especially when you are out in the field, when you're trying to do analysis and all that. When the p-value is greater than alpha or the type 1 error, usually set at 0.05, then you fail to reject HO. When you have a p-value of less than or equal to alpha of 0.05, then you reject HO. So these are 3 things or 3 ways on how to assess. And then later on, I'll be demonstrating some of them. But of course, when we go to the use cases, we'll be using TUOS, which will give us like I would preempt already p-value. Okay, but I'm gonna show you how these are being used in one simple use case. Okay. All right. Now we're talking about steps in hypothesis testing. So if you have questions, please make sure to have your question ready later on. I'll be answering questions at the latter part of the session so that we can consolidate. Right. So what are the steps? So here are the 8 steps to hypothesis testing. Number 1, state a practical problem. Okay, what do you want to prove or disprove? What is your hypothesis? So that hypothesis, state that in a statistical way. How do you do that? You create your hypothesis statements, your HO and HA. Select the confidence level and power level. We'll be talking more about that later on. Determine the sample size and collect the data. Select the appropriate hypothesis test. 4 and 5 is a little bit, I would say, if you look into some other literature or like guide steps, it could be like somehow mixed up or combined in one. Okay. Run the statistical test, do the analysis. Interpret the results using any of the 3 approaches provided: critical value method, confidence interval method, and then p-value method. And then convert that statistical solution to something that's going to be practical for your consumption. Right? So I'll be giving you a use case. Okay, I'll be giving you a use case without using TUOS yet, just for you to appreciate. And then we'll jump into examples using TUOS later. All right. So for example, suppose a researcher wants to test whether the mean weight of a certain population of dogs is equal to 20 kilograms. Okay. So that's going to be the main theme of the use case. So let's have it step by step. Step number 1, what is the practical problem? So the researcher, sorry, that should be researcher. My apologies. The researcher wants to test if the mean weight of a certain population of dogs is equal to 20 kilograms. So the hypothesized, so when you say hypothesized, this is the value that you're suspecting, or let's say the value that has been set as a standard, something like that. So either or. It really depends on what do you want to learn or to know about the data set and the population, let's say. So they want to determine whether the average weight of this certain population of dog is 20 kilograms. Now, how do we state that in a statistical problem? How do we use the hypothesis statements to convert that into something that's statistical? So there could be two ways on how to do this. I mean, you could be as creative as possible for as long as the context of what you want to discover from the data set is there. So it would be HO, average weight of the dogs, is equal to 20 kilograms. And HA, average weight of the dogs, is not equal to 20 kilograms. So you have to be reminded that in HO, what we are looking for, or what we are setting as the one that we're testing, is that there is no significant difference. All right. So it only means that if the average weight of the dogs, the certain population of dogs, is equal to the hypothesized one of 20, so there's going to be no difference at all. That's why is equal to. Okay. Don't be confused. Sometimes people get confused because it's equal. Okay. They're finding like not equal because there's no significant difference. They relate it to something that, hey, that should be on the HO, right? Not equal, something like that. So it's equal, therefore there is no significant difference. Okay, so that's gonna be HO. While HA, it's not equal to 20. If it's not equal, there's gonna be there is a significant difference. All right. Now, what is the other way to do this? So HO, there is no significant difference between the average weight of the dogs versus 20 kilograms. So there is no. And HA, there is a significant difference between the average weight of the dogs versus 20 kilograms. So that's basically step number 2. Step number 3, let's talk about confidence level and power level, so that before we set it, you know why we are setting this. So type 1 error, also known as alpha risk, also known as producer risk, is rejecting the null when you should not. Don't worry, I'll be explaining this using a matrix in a short while. So it's like you've discovered something that is not there. While type 2 error, or beta risk, or consumer's risk, do not reject the null when you should. You've missed a significant effect. All right, so don't be overwhelmed. I'll be explaining this as practical as possible in the next slide. All right. So why do we have this kind of errors? You might be wondering, okay, why do we have this kind of errors? We have this kind of errors because we're talking about probability and statistics. In probability and statistics, there are only few things in the world that is certain, and everything else is uncertain. That is why there is probability and statistics, correct? So when you are deciding, when you are doing a decision, when trying to come up with a decision, what happens? You use data, and sometimes, and most of the times, of course, you're not 100% sure. That's why the level of confidence in our decisions varies from one decision to another, right? All right, that's why there are susceptibility to certain types of errors. Okay, and now I'm gonna explain it the most practical way possible. Okay, so when we're doing hypothesis testing or decision making, there's again two hypotheses, right? We fail to reject HO, or we reject HO. Okay, and there are like two conditions that could happen. So it could be like the HO is true and the HO is false. Okay, let's do some annotations here. So when you fail to reject HO, when your HO is true, okay, so that's a correct decision because you haven't rejected HO because it's true. Okay, so that's correct. That's a correct decision. When you reject HO, all right, when your HO is not true or when your HO is false, that's another correct decision, right? You made the right decision. And here are the errors. When you reject HO, okay, you reject it, but your HO is true, what happens? You have now a type 1 error. So meaning you've rejected something when it is true. Okay? That's the type 1. The type 2 error is something that you failed to reject, so you did not reject HO when it is false. That is why you'll be having a type 2 error. Okay? So let's try to make an analogy. Let's just say, let's say a phone. You did not reject the phone, or you accept the phone as good when the phone is good. That's correct. You reject, sorry. You reject the phone and you say that it's not good in good condition when it is not in good condition, and that's another correct decision. Where are the errors hiding? You reject a phone when the phone is good. The phone is in good condition, so that's type 1 error. Okay? You accepted the phone, okay, when the phone is not in good condition. That's going to be type 2 error. Okay? So that is why type 1 error, when producers reject something that is in good condition, that's going to be on their risk because they've lost resources in doing the phone and then only rejecting it while it's in good condition. While on the consumer side, the type 2 error, that's why it's called the consumer risk. You accept a phone as a consumer when it is not in good condition. Okay, that's the reason why it's being called here that the producer's risk, and this one the consumer risk. Okay, hope that makes sense, right? So let's try another example. So we still use the same matrix, and this is like a meme that I've been using in my classes inside my, or to run Six Sigma classes, statistics classes on my previous organization. So type 1 error or false positive, you're pregnant. Look at that picture. The doctor telling a man that he's pregnant. And then type 2 error, false negative, you're not pregnant, telling this woman that is obviously pregnant. So if you see, unfortunately I have covered the baby bump there. Okay, so let's try to understand. So not pregnant, pregnant, and then when HO, which is not pregnant, is true and false. So you say that someone is not pregnant when the truth is they are not pregnant. That's correct. You say that someone is pregnant when the truth is they are not pregnant. So that's going to be some types of error. So this one, type 1 and type 2 errors, these are manifested in this particular matrix here. Okay. So for us to better understand this, okay, let's talk about the confidence level. 1 minus alpha, or you say alpha is the type 1 error, right? So usually at 5%. So confidence level is the confidence of the test. Confidence level that the test possess, okay, using this set of data sets, okay, or data set. So usually it's set at 95%, so that alpha becomes 5%. So they are complementary. Confidence level plus alpha will always be 100%. Okay. Same with power and beta. So power plus beta is equal to 100%. So what is power? Power is the ability to detect the difference. Usually this is influenced by the number of samples. Okay. This should be set at 80% and beta at 20%. Sample size selection is a very big topic. Okay, I would say very big topic. In terms of statistics, it's like one subject if you're taking a statistics class. Okay, so we will not dwell too much on that. Okay, but if you're interested, you could approach me offline. Okay, so determine the sample size and collect data. Again, there's gonna be a way for us to calculate. So for for the purpose of demonstration, let's just say, okay, we've collected much number of data and we're using it for the test. Okay. So this is step number 5 already. Step number 5. So step number 4, determining sample size and data collection, actual. And then number 5, selecting the appropriate hypothesis test. So we have, in terms of normality of data, when you say normality, whether it follows the normal distribution or not, there could be 2 tests, or there are 2 tests that could be involved. The non-parametric, the parametric and the non-parametric. So when you say parametric, we've checked whether the data is normally distributed or not. And non-parametric, we say that we use this when the data is not following the normal distribution. Okay. So for this particular case, we would assume that we have a parametric, we have a normally distributed data set, so that we'll be using parametric tests. Okay. So in let's say, okay, for example, this one is a sample roadmap of hypothesis testing. I'm gonna share very quickly how it's being used. Let's say we start here. We ask ourselves, what is the type of data that we have? We have weight of dogs. Dog weight or weight is a variable data. Okay, so variable data, I go here. So how many factors are there? We only have one factor, weight only. Is the data normal? Assuming that the data is normal, in real cases, you might want to check it, okay, using normality test. So normal, data is normal. How many levels? So how many, let's say for example, your factor is dog weight. So is dog weight like light or heavy, something like that? But if there's none, so there's going to be one level only. You're just looking into dog weight, so that's going to be 1. And then what are you testing? We're testing for the average, so means. So that will lead you to using one sample t-test. So this is a very helpful hypothesis testing roadmap. I also used this for mentorship for my Lean Six Sigma green belt and black belt students. Okay, so for this particular case, we'll be using one sample t-test. Sorry. So then you run the test. I'll not be showing anything yet. This is the by hand method. Later on, we'll be using the use cases. Okay. So I'm gonna I would want to heads you up that this, I think, would be like an hour and a half, maybe 90 minutes webinar. And I hope you could stay up until the end, okay? Because this is really helpful for you guys. So we have critical value method, we calculated that. Confidence interval, we've calculated that. And then p-value method, we've calculated that, okay? So pretty much, let's say if you're using a software platform, like say for example, TUOS or Minitab or SPSS or even Excel, depending on the complexity, so you can like get all of this. Okay. So when you have successfully run the test, next one is you have to interpret. So before you interpret, you have to recall your hypothesis. So HO, average weight of dogs, is equal to 20 kilograms, or HA, average weight of dogs, is not equal to 20 kilograms. Okay. The critical value method, confidence interval, and p-value method are now presented, or that have been presented. So what I did is to recall how is the decision process. Okay. So here, supposedly, okay, I think I haven't experienced so far in the last 11 years that they are pointing to different directions. I mean, when someone tells you, or if one of the tests is telling you that you have to reject HO, the rest will be the same, something like that. Okay, so let's say critical value method, just for the purpose of demonstration and appreciation. So your test statistic is absolute value is 3.16, and 3.16 is greater than the critical value of 2.009. This is based on the critical values from the table with degrees of freedom of 49, if I remember it right there, and under the student's T distribution. Okay. So what is the rule? Critical value when the test statistic is greater than the critical value, we reject HO. So we reject HO. Okay. So we calculated also the confidence interval. We say that the average is 18 kilograms, okay, here. And then we apply this factor here, and then the t-value, we were able to get the lower interval at 16.45 and 19.55. The question is 20? Why 20? Because 20 is the hypothesized value. We're comparing whether the population, average weight of the population of these dogs from the sample data is same with 20. So is 20 kilograms within the range of 16.45 kilograms lower interval and 19.55 upper interval or higher interval of the average of the weights of 18 kilograms. So we can see that it's not within this interval. So what's the rule? Hypothesized value of 20 not within these intervals of 16.45 and 19.55. Therefore, we reject HO. Okay? And p-value method. Okay? The p-value method or the probability that we're having an error is what? At 0.002, which is usual value of alpha is 0.05. Okay, don't forget that. So what is the rule? P-value which is less than or equal to alpha of 0.05, you should reject HO. Okay, so pretty much all of them would be pointing out to the same direction. In short, therefore, what happens? Therefore, could we convert the statistical solution to a practical solution? Therefore, the average weight of the dogs in the population, that should be population, sorry, is not equal to 20 kilograms. Or I would say I could say also that there is a significant difference between the actual average weight of the dogs versus 20 kilograms. I could say that. Okay? So that's pretty much how the hypothesis testing steps work. Okay? So if you have questions, please make sure to have them in your notes, and later on we'll try to discuss. Okay? Sorry, excuse me. So let's apply this to finding the relationship in variables that matter. Okay, so that's just pretty much the surface, but this one will be very quick because if you've understood how it works, I mean, if you've been refreshed of how it works, this will be a little bit easy. Okay, so let's try to revisit the y as a function of x. But before me going into the details, please make sure that if you would want to participate in the discussion later on, or probably if you would want to do the exercises, make sure to download the data and to access your TUOS accounts or profiles. Okay. So let's revisit y as a function of x. So when you're doing your research or your study in your company, so this is pretty much the way how it goes. It follows a structure, especially in Lean Six Sigma. This is a very helpful structure or a very helpful model. Y as a function of x, pretty simple. For every known effect y, there are known causes x's. Okay, so for example, for the sake of us being into the case, let's say that y is the statistics prelim exam score, or simply score, exam score. And the exam score is affected. So we're talking about the possibility of the exam score being affected or influenced by certain factors. So for example, we have the time when studied, either morning or afternoon, or morning and evening, AM or PM. We have X sub 2 with or without notes taken. So the state wherein you're taking notes. X sub 3, the duration of preparation for the exam, the duration of sleep, and location of the seat in class. Okay? So hypothesis testing. So pretty much we're trying to figure out whether all right, so is my score affected of the time that I studied, the availability of notes when I'm trying to study, the time that I have put into preparing, the time that I have spent sleeping before the exam, or is it something that is affected by where I was seated during the classes, something like that. Those are all hypotheses, guys. Okay, and the reason why I put the title "Finding the Relationship That Matter," it's because in research, or even in the actual scenario, in the actual workplace, sometimes we forgot that, hey, you need data, you need to prove that, that there's a relationship that really exists between your y and x, so that you can focus your energy, you can focus on factors that really matter, and that would, when you optimize it, it would give significant impact on my y. Okay, and this is common problem. I am telling you, this is a common problem to, problem solvers, process improvement professionals. They forgot to do this. They I don't know if they intentionally forget to do this, or is it something that they are not comfortable doing, because there's a lot of resource that is tied up on things that we would be doing, and not really impacting the way we do the business, or the way we are operating inside our organization, something like that. So I hope this will cut across. Okay, so again, shameless promotion, please download your TUOS now, or access your TUOS Alpha, tuos.com. If you're having a difficulty, there's like a slide, there's like what do you call this, not slide, like a page there. You have to click in the 90-day trial before you have to click next. I think sometimes you're clicking next without highlighting that or clicking that. That's why there's going to be some sort of error. But hopefully you are now you now have activated TUOS for the next couple of slides. All right. So let's try to figure out which among these 5 really matters. Okay. So let's start with, so we'll be doing this one based on the presented 5 variables. So we're trying to figure out what are the variables that could significantly impact the exam score on my prelim exam on statistics. So first, my practical problem would be the exam score is affected by the time of the day when I studied. Okay. So, but before anything else, can I just share my screen for, wait, let me just prepare my, okay. So this is, by the way, TUOS. Okay. And I hope you are seeing my screen. So this is cloud-based, so you don't have to install. So what I did earlier was to copy paste the data that I provided you in the Google Drive link. So I just copied it here. Okay. And so I just pre-process it this way. And so we will be using this. And okay. All right, so okay. So what is my practical problem? Is exam score affected by the time of the day when I studied, either AM or PM? So I'm going to convert that into a statistical problem. There is no significant difference between exam scores when studied during AM versus PM. Or there is a significant difference between exam scores when studied during AM versus PM. Okay, so the factor here is the time of the day. We call it the factor. The levels of the factor is either you studied AM or PM. Okay, again, time of the day is called a factor, and levels are the levels of the factors. Either it's AM or PM. So pretty much this is how it works. I mean, this should be your your frame of reference or the way how you would think about this. If the time of the day is not a significant factor influencing exam scores, therefore, the exam scores of people or of students who have studied for the exam on AM should be the same or should be not statistically different with people who have prepared for the exam on the PM time. Okay? But if time of the day is a significant factor, we will see that there is a difference. There is a significant difference between the scores of those who studied in either morning or afternoon from the other group. So that's pretty much how it works. So step number 3, alpha at 5% or at 0.05 and beta at 0.2. But pretty much you'll just be seeing the surface of these two in the form of confidence level. Okay. The number of samples collected was 40 samples, and based on the hypothesis testing roadmap, because I have 2 variables, 2 groups that I would want to compare, I'll be using 2 sample t-tests. Okay. So how will it work? So let me go back to TUOS very quickly. All right. So I'll be using this data set since TUOS as of the current moment only accepts columnar data sets in groups. So one column of data is representing one group. Okay. So we just have to go to analysis. Of course, there are like basic stat functions here. We go to 2 sample t-tests. So you can use this for your research. You can use this for your company study. So column 1, let's just say column 1 is in column G. So that is the column for the exam scores. That is from the who studied at AM, and the adjacent column would be exam scores who of students who studied on PM time. And let's click maybe box plot. So you have here option to not to have like a visual or graphical analysis, but for me, I would suggest that you use either at least box plot so that you see how it looks like. Okay, and then you just have to run the function. All right, so you see here that the difference between the score is 16.15. Okay, these are some of the parameters here, and the hypothesis, the null, and the alternative. So you will be using p-value for here. We don't have yet the confidence interval. It's in the roadmap, but in the most common scenario, we'll be having the alpha value. So this one is, it reads 1.28 times 10 to negative 11. Okay, so it's a very small value, almost 0. Okay, what's good about using TUOS, of course we're using TUOS, is that there's a note here, and I think this is not pretty much typical. It's not typical for software, analytics software, data analysis software to have this. So this one, it has the note already. Okay, so since p-value of column G and column H is less than 0.05, therefore reject null hypothesis and conclude that there is a significant difference between the mean of column G and mean of column H. So see, and there's this box plot. So you can see here, when you look at the AM, they tend to have like what, higher scores, like between, let's say, 83 to 90, while this one we have like around 70 to 75. For some reasons that we will have to discover yet, this is what happened. Now, if you would want to enlarge the view, you can use this and this one. Okay, so that's the first example. Now let's go back to the hypothesis testing steps. So these are the output earlier. So how would we interpret? Because we have p-value of less than 0.05, that's 1.28 times 10 to the negative 11. So we reject HO. Therefore, there is a significant difference between exam scores when studied during AM versus PM. And eventually, what's going to be the practical one? The practical one would be suggesting, not enforcing, okay? To if they could study in morning. Me as a person, I'm a person who study early, review, no, in the early mornings. It's because my mind is have rested already. Unlike if you're trying to, cram and all that in PM. This is just me. It's not a study, a scientific study that you have to follow, but it's, just me. You have to um put context, of course, no? But for the purpose of this simulation or for this use case, it says that it's better to study in the morning because it yields better exam scores. So this is what I'm telling you. If you see that there's a difference, so it only means that that factor is significant to your Y, which in this case is your exam score for prelim in statistics. So that's going to be the time of the day. So we would say that, all right, the relationship of exam score and time of the day is significant. All right, because it yields to having this statistical conclusion that we have, that there's a significant difference between exam scores when studied during AM or PM. Okay, so this one is pretty much the same, note taking. So exam score is affected by taking or not taking notes during lectures. Okay, so there is no significant difference between exam scores when taking or not taking notes, or there is a significant difference between exam scores when taking or not taking notes. Okay, alpha at 0.05 or a 95% confidence level, same sample size, and the same data, two sample t-tests will be using that. Just to demonstrate how you do it in, pretty much it's the same with the earlier one. Yeah, so I'll not demonstrate it anymore. So it's pretty much the same data set. Okay, so the same p-value applies. So what I'm trying to reinforce here is that the difference that you're seeing, if there's a difference between the levels of the factor, then basically that factor is a significant factor to your Y or to your response. Okay. How about duration of study? Of course, when you're trying to prepare for the exam, your hypothesis is that, okay, I'll be getting like higher exam score probably when I study a little bit. I invested more time to that. Okay, so let's see how our hypothesis will hold. Okay, whether it's valid or not valid. So from that practical problem, let's say there is no, for HO, there is no significant relationship between exam scores and duration of study, or there is a significant relationship between exam scores and duration of the study for my alternative hypothesis. So same confidence level and power, same sample size, but this time a different test. We're talking about correlation. So what is correlation? Very quick hand, no? Correlation, this is a study that we do to check the possible correlation or relationship between two quantitative variables in the most surface level. Okay, if you go to higher order of course correlation regression, you'll see that it could be like qualitative and all. But as simple as it may be, or as simple as we want to get there, correlation as quantitative Y, quantitative X. So okay, that's it. So let's go to TUOS. All right, so all right, so we have to get the correlation between the exam score and the duration of study. So let's try to use graph. So go to graph and then simple scatter plot. So x-axis would be letter D or column D. That's the duration of your study. And we want to correlate that to the exam score. So you might want to click also this one, the regression line. Just to give you a quick background, when we talk about correlation, we're typically looking at the regression line, whether there's a slope. Okay, again, we're talking about change. If you're changing from one data point to another, probably your X that you're pairing, let's say the duration of study, is something that is significant to your Y, which is the exam score, because there's like changes. Okay. So let's run the function and see. What's good about TUOS, it's user friendly. Sorry for the shameless plugging. But yeah, you would see also the results here. Okay. So we have here a Pearson's R. What's a Pearson's R? It's the measure of the relationship between your Y and X. So this one is 0.1512. What does it mean? It only means that we have like -1 to +1 correlation. So the nearer it gets to -1, the stronger the negative correlation becomes. Okay. The nearer it gets, or the closer it gets to +1, the stronger the positive correlation gets. The nearer the value the Pearson's R goes to 0, it only tells us that there is no possible correlation between the two variables, or relationship between two variables. Okay. So how do you check whether, okay, sir, I'm seeing like a value of the R here. I'm seeing that that's positive. You can also look into what? To the result here, that the slope is leaning to the right side, okay? Because of the line here. So it's like there's like a, I would say, weak positive correlation, but how can we assess? That's why we put the p-value. So we will use the p-value to assess whether the relationship, that the correlation that we're seeing, is it significant or not significant. Okay, the p-value will tell us that. So we go back to the PowerPoint. Okay, so I have a p-value of 0.3518, referring to the Pearson's R of 0.1512. What does it tells us? So the p-value is greater than 0.05. So what will be my conclusion? My conclusion would be fail to reject HO, because p-value is greater than 0.05 or greater than alpha. Therefore, there is no significant relationship between exam scores and duration of study. Meaning, it doesn't matter how short or how long I study. I mean, the score will not be dependent on that particular variable. So I would not put any like I would not put any special attention to how long or how short I am preparing for the exam. Again, this comes with context. I mean, this is just for the purpose of this particular study, and this is not something that's scientific. All right, so don't get me wrong there. Okay, so that's going to be duration of study. Okay, how about, so it turns out that, hey, that's not a valid factor. How about the duration of sleep? Maybe it's something that the longer I sleep, the higher the score is, or the shorter the sleep, the lower the score is. Well, sorry, if I could step back a little bit. So it tells us that x-axis is the duration of preparation or study, and then the y-axis here is the score. So meaning somehow there's like some sort of a very weak relationship, that the longer I prepare, this is the x-axis, okay? The longer I prepare here, what happens? The higher, supposedly, the higher the score it gets. There's a very weak positive correlation, but that correlation is not enough to become significant, to become a significant factor affecting really the exam score. This is how you read it, okay? All right. So how about the next factor? The next factor, and we're about to finish, no? Exam score is affected by the duration of sleep. So my HO would be, there is no significant relationship between exam scores and duration of my sleep. And HA, there is a significant relationship between exam scores and duration of sleep. So again, same power and confidence level, same sample size, and we're gonna use correlation because I have exam score quantitative and I have duration of sleep in hours or in minutes, maybe in quantitative form. Okay. So let me again show you using TUOS. So pretty much the same. Go to scatter plot, and the x-axis is letter E, which is the duration of sleep, and then your A would be your exam score, or your y-axis would be your exam score. Put the regression line and then run the data. Okay, so if we would compare, it's a little bit lower compared to the first correlated factors. That's the exam score and the preparation, duration of preparation. So 0.1264, another p-value that is greater than 0.05, which tells us that, hey, this is not a significant factor. There's no significant relationship between my exam score and my duration of sleep. Okay. So you can also try out correlation here, basic stat, correlation, and then A and E, and then Pearson's R. You could use also the scatter plot here. Okay, so same here. If you can see here, like these are printed. Fail to reject. There's no significant difference between the mean of the variables. Okay, or there's no significant relationship between the variables. Okay, so that's pretty much how you use TUOS for correlation. And then of course, last would be, is it something, is my exam score something that's affected of where I am sitting? So we were able to like have three layers or three sections. That's the front, mid, and back. Okay, so the HO would be, there's no significant relationship between exam scores and location of the seat in class, or alternative, there is a significant relationship between exam scores and location of seat in class. So same parameters for 3 and 4, and this time I'll be using ANOVA. Why ANOVA? Because I have now one factor, which is by location, but I have 3 levels. Either you sit in the front section, mid section, or back section. If it's 2 levels, then you can use 2 sample t-tests. But if it's more than 2 levels, you can use ANOVA. If you have 3, 4, 5, 6, and so on and so forth. Okay. So let me show you how to run the test again in TUOS. So analysis, ANOVA, one-way ANOVA. So variable 1 would be M. So I put it there in the rightmost columns. N. So I have to add another variable, and O. So I can use box plot here and just run the function. And then just have to wait for a couple number of seconds. So if you look into the box plot, what do you see? They're almost the same. So, but just by looking into this, you would have an idea that, hey, pretty much they're almost the same. So it doesn't matter where you sit. So that's not a significant factor. So the p-value, you could validate using the p-value. It's 0.4744, which is greater than 0.05. So which tells us that, hey, we fail to reject HO. Therefore, there is no significant relationship between exam scores and your location of seat in the class. Okay, so that pretty much sums up how we find the significance between your Y and your X's. Okay, so what are my, sorry, this should be my reflections on hypothesis testing, because I've used this in a previous engagement. So number 1, hypothesis testing helps differentiate events from those being due to chance and those due to assignable factors. Data availability and integrity is critical to make it work. Garbage in, garbage out. Okay, so if you're like data is full of errors, then you'll have like a decision that is based on errors. And the ability to interpret the results and draw insights from data is always king. Right, so with that, let's continue to be #significantly better through accessible and sustainable lifelong learning together. And I'm now open to any questions that you might have. This will be very quick. I mean, we're done 8:30. So if you have like questions, please drop them now. So I have here one question from earlier part of the session. What is your take about a research that was not able to prove that the alternative hypothesis is accepted? Do you think that the research is less valuable? You know, when I was younger, I'm now doing my PhD in industrial engineering by research. And it was thought to me by several mentors way before. The goal is not to really have, the goal is not to reject HO. It's really based on, because these are hypotheses. So it could really go either you fail to reject or reject. It doesn't matter. I mean, for me, if I understood your question correctly, it's not a matter of, hey, this one proved that this is correct, or the hypothesis is correct. It's more valuable or so. It's really based on the context of or the research questions and the data that you have uh gathered. So sometimes and this is where the hypothesis testing errors would come into the picture. You have to understand that, hey, maybe this one is, we don't have enough evidence because the sample size is not enough, something like that. And when we talk about sample size, it's very tricky. I mean, we've known some like formula like the Slovens that's been helping us in calculating the number of, I mean, yeah, in determining the number of samples or the number of respondents, something like that. But it doesn't always the case. Sometimes it's very specific to the test, and then you apply the sample size calculation based on the test and the specific difference that you would want to apply. It's not really a matter of, finding a number and then distributing the questionnaire and then getting the data and then running the test. It's really more to that. There's more to that. Okay. So I would say it's really dependent on your I would say research question and the way how you've collected the data, because that would lead you again to the quality of the research or paper that you are, or the study that you are doing. I hope I was able to give light to your question, sir. Another question. In doing research, what will be the basis of specific value of confidence interval? All right, so this is a very good question. Typically, if you're running a typical paper, that's going to be 95%. That's a rule of thumb. That's a industry standard. But depending on the criticality, let's say, for example, the process is too critical. You're doing like a research for a company that has a critical process, or that the products or services that they're doing is very critical. Like if you're doing this for like a reference for a change that needs to be done, you may want to be very critical. So what do we mean by that? You might want to increase your confidence level from 95 to, let's say, 99, something like that, or 9. So I would say 97.5 or 99, something like that, or 99.5. So that could, it would depend on how critical. Okay, if it's a typical study, that's going to be 95. It's if it's a little bit loose study compared to the usual, you could go for 90. So because this confidence confidence level would affect your hypothesis testing or the test that you're doing, because there's a factor that is based on that. Okay, so when you go for like 90% confidence level, your type 1 error, you're accepting as much as 10%, something like that. But if it's too critical for you, let's say 99%, your room for error in terms of your decision making, type 1 error, right, earlier, is 1%. So that's how we try to set, based on the criticality of the process or the products or probably the research. I hope I was able to answer your question. What else? What other questions do you have? All right. So if you don't have questions anymore, I would say thank you for being with me for the last 90 minutes. Let me try to move to this one. Okay. So, and it was me, your facilitator, for finding the relationship that matters, hypothesis testing using TUOS. Okay. Let me try to search for the link. All right, so okay, so all right, so again, thank you for our partners, iExcel, Blessed, formerly Grace Apparel, TUOS. Of course, please don't forget to get your 90-day trial. It's ending soon. It's gonna be from 90, it's gonna be 30, and from after 30, you have the option to subscribe on a monthly basis or annual basis. This is like Minitab or SPS, but way more cheaper. So Startup Podcast PH. Follow us, please, in our Facebook, Instagram, LinkedIn, Twitter, and YouTube channel. Ask the Speech Academy or askthespeech.com for more free courses. We have online courses that will be happening soon. Lean Six Sigma Yellow Belt on March 25th, 26th, April 1st, and 2nd. Okay. We also have self-paced Lean Six Sigma. We have Green Belt happening. This one is adjusted to April after the Holy Week, I think. We also have self-paced Green Belt. We have Black Belt. This is adjusted also after Holy Week. We have Project Management Fundamentals happening this March 25th. We have the Kaizen Professional on the 25th and 26th of March. We have a new program called Data Engineer happening very soon. And you can register as a group of 5 and pay for only 4 person. That's additional 20% discount on top of the published discounted rates. We're actively looking for partner organizations and partner businesses and also for ambassadors. So you can earn as much as 5% referral when you become one. And of course, don't forget to visit our free courses at asklikespeech.com. And we have a lot of good things in store for you in the next coming months because we are having this big surprise. So please watch for that surprise. And okay, so this is the link, right? So all you have to do is to fill out the form. I also shared this in the YouTube channel. So fill out the evaluation form, and the attendance link will close after 30 minutes. Don't forget to provide the correct details so that you have you can receive your e-certificates as fast as we can. We apologize for some delays, but we are trying our best here. So that's going to be the session for this evening. Thank you again for being with me for the last 90 minutes of your day. And I hope you learned something about finding the relationship that matters using hypothesis testing using TUOS. So again, let's continue to be #significantly better through accessible and sustainable lifelong learning together. Thank you, everyone. See you again in our next learning session. Bye. Don't forget to support us in our social media accounts. Bye. Thank you.